Hey everybody, hope you're well. I'm gonna try some new stuff today. For once, you can see me. You may have seen me a few times in some videos before, but most of the stuff that I've done, you haven't been able to see me. In addition, what I'm going to talk about today is a little bit. We're going to go back a step or two and talk about kind of an introduction to statistics and why it matters. Up here, you can kind of see that I have some notes for once. This is what I normally look at, and I'll be looking at these, but I'll be drawing stuff on the board again. We're going to just try to introduce statistics. I think I'm probably going to get through things worth knowing about data. We'll probably save the rest of this for another video. I just want to give you an idea of what we're going to be going over today. So what is statistics? Well, what we're interested in, the things that we're going to be talking about are populations, right? What statistics concerns populations. Nope, there we go. And that's the first thing that we're going to kind of deal with. That's what this is the study of, right? So when we talk about geology, geology studies rocks, among other things, but you know, the rocks and the history of rocks and what that can tell us about lots of things. Economics, which is my field, we study behavior of individuals. That should be an S there. You know, we study the behavior of firms, economies, if you're in macro, the choices they make under scarcity. In econ, we study populations and characteristics of populations. The way we do this is we use samples, right? So we can't look at populations. We'll talk a little bit more about what populations are in a moment, but the key thing to think about populations is that they're really big, right? So but that's what's important, right? The wide world out there is the population, and we can't see a population. It's just not possible. It's too large for us to wrap our heads around. And so what we do as human beings is we you know, particularly as you know, eggheads who sit in offices, is we take stuff we can see, right? So what we want to do is we want to be able to look out our window, or maybe even look inside ourselves, or at a room full of a focus group, maybe. We want to be able to take what we learn within a focus group or out our window. We want to take that information and use it to have really big conclusions. And that's, you know, that's basically what statistics is for. It's really, to an economist, it's delightful because understanding populations is impossible. But understanding this, understanding what we'll talk about as samples, this is really economical, right? We're bringing people in somewhere and into a room, and then we can ask them questions, and it's easy to ask, and it's cheap to ask 30 people questions. In the U.S., we try to run a census, right? The biennial census, is that what you call it? Every 10 years we have a census, and it's really super expensive. And so what we want to do is be able to get more for less. In some cases, you know, be able to do some stuff, right? So if we want to talk about all the coin tosses that have ever existed, that's a population that's just uncountable. It's not possible to observe it, and so we have to take a sample of necessity. Okay, so what we're going to do is we're going to take this and use this to make guesses, to guess about this, about populations. That's where we're going to get to, right? But we're not there yet. Where we're going to start is with data. Data is raw information, right? So it's kind of information without any meaning yet. It's just, you know, collected stuff. And just in selecting what we collect as data, you know, we're applying some meaning to it, right? We're not just taking any random thing. You know, there's some selectivity that goes into collecting data, but there's more meaning that can be gained from that we haven't gotten to yet. So that's what we're going to talk about. One of the things I kind of want to make it clear in this, you know, right now in this video is that this is really important. The way that I often say this is that, you know, in algebra, a lot of the heavy lifting has been done, the stuff that we can do with algebra, right, which was super useful. Algebra is really handy if you have, let's say you have a cannon. That's what this is. This is a cannon, right? And what you want to do is you want to understand, okay, so if I fire the cannon like this, it's going to hit something here. And if I tilt the cannon, right, let's give ourselves just sort of a counterfactual cannon. Let's say we tilt it up a little bit. Well, then what's going to happen? Well, thanks to algebra, you know that it's going to go, I don't know, here maybe, right? And so depending on what we want to hit, and depending on air resistance, right, these aren't perfect parabolas, then algebra can tell us, okay, well, how do we want to tilt our cannon? Trigonometry too, right? And that was super useful. Algebra was really great, and still remains really great, but it was really great for cannons. But algebra was invented kind of a long time ago. Statistics is still really young, which means that there's still money on the table as far as statistics is concerned. Okay, there's money on the table now. Most of the people I teach are in the school of business. To them, that's enough. Maybe to some of them. To me, I don't know. I have more of a philosophical bent. And what I really want to do is I want to understand the world, right? The world is big and complicated. And so another way to say this is that there's stuff we don't know. Some of it is a profit opportunity. Some of it is just intellectual curiosity. I apologize for that handwriting. It will improve as I get back in the swing of this. But in any case, there's stuff we don't know, and statistics can help us solve that. So where do you find statistics? Well, I looked at in my web history, so where statistics are. I looked in my web history just to see what I had found statistics on in, say, like the last 24 hours. One of the things, we were looking into buying a new used car. And so I have, what we have is that, I don't know if you guys have seen this, but there's the Edmunds TMV, True Market Value Price. Well, we're getting a minivan. We had a second kid. He's about 1.5 years old, and we have a childcare co-op that we just restarted, and so we need a minivan. Well, what do we want to know? Well, I've never bought a minivan before, right? So I can't rely on my own experience for how much I should expect to pay for a minivan. And so what do I want to know? Well, I want to know, how much does a Honda Odyssey go for, right? I don't want to get screwed. I don't want to spend more money than I have to. I want to give a fair price, right? I don't want to offend anybody. And so in order to do that, what's useful would be to know, well, how much should I offer, right? What's the price that's going to get me laughed out of the room? What's the price that's going to make the other person kick his heels together and think, I can't believe I found this guy who's willing to pay a ridiculous amount for this car? Moreover, okay, so let's say I'm indifferent between a Honda Odyssey and a Toyota Sienna. Are the prices different on average? If they provide the same subjective value to me, right? Like I don't actually care whether I get one of these or one of these. Well, which is cheaper, right? Which could I get for less is what I want to know. What Edmunds does is it gives you what's called a conditional mean. Conditional mean says, tell me all of these things about your car, right? Tell me the make, the model, the year, the mileage. They have some kind of condition, right? So is it in excellent condition? Is it in good condition? And they know a bunch of other stuff, right? They know like the gas mileage and stuff, and they say, okay, well, given this would be the average retail price or sales price. And they give you a couple conditional means, because they'll tell you the price at a private party. They'll tell you the price if you're buying it from a dealership or certified pre-owned and all of that stuff, right? Now, where do they come up with this? Well, they're not just making it up, right? I mean, they're not. I mean, as far as I hope not. They wouldn't stay in business very long if they were just saying, okay, tell me a bunch of stuff and I'll pick a number out of a hat, right? They come up with something, and so there's a question there as to whether. As to how do they get this? Well, the way that they get this is they collect a lot of data. So they use data, and then they take that data, and then they use statistical analysis to say, okay, the one we ended up buying is different in fundamental ways than any car that has ever been bought, right? It's a specific. We ended up buying a 2002 Honda Odyssey. We were looking at 2007, 2008 cars. We happened to find a 2002 Honda Odyssey that was owned by somebody that we happen to know, who we know happens to be somebody who takes good care of cars. So we had information that was better than the information that we could put into this model. But still, they were able to give us some idea. Okay, so we had a 2002 Honda Odyssey with, I don't remember, 70,000 miles on it, 80,000 miles on it, and it was in very good to excellent condition. And so the they use statistical analysis to say, okay, well, based on other cars that are similar, we can tell you something about this is the price, this is the average sales price for a car like this. And we were able to, make it come to a consensus with somebody we knew about that. The one we settled on has a VHS video system. How much should that add to the price of the car? Well, it's hard to know. It's possible to answer how much that's worth conclusively by collecting data, though. Okay, so what else did I do? Where else have I found statistics? Well, I bought some video games. Okay. Now, I don't know if you've ever heard of this, but one of the things I bought is called a Humble Indie Bundle. I highly recommend it. It's independent video games. And you get to, it has a pricing model where it's pick your price. So, there's like 5 or 6 independent video games. You choose a price that you're willing to pay. And let's call that P. And if P is greater than the average price, the mean, call this the mean, that's the letter mu. We'll talk more about that later. Mu. If P is greater than the mean, then you get bonus prizes. Well, that mean has been calculated, right? They calculate the mean. That's a statistic based on existing people. It's really good. I'm just going to endorse it straight up because some of your money goes to independent game producers, and some of it goes to a charity called Child's Play, which is a really excellent charity that buys games and movies and books for kids who are in the hospital to help them. There's good evidence that when kids are happy and smiling and stuff, it helps them heal faster, and so Child's Play is designed to try to harness that. But other stuff, I use Mint.com, another endorsement. Personal finance, it's kind of important. You should, at some point start paying attention. Mint.com makes it really easy to track your expenditures. And one thing it does is, let's say you have car insurance, and your car insurance is really expensive, and it's not a good idea. Well, if your car insurance is a lot higher than the mean, what it'll do is it'll kick you to recommendations. And so it can take advantage of the sample that it collects to get an idea as to whether or not you're spending too much. It also calculates your average expenditures by category, and it can use that to help you make a budget, right? So if you spend a lot of money on restaurants, $50 a month on restaurants, then it'll tell you, hey, this is how much you spend on restaurants. Either put in your budget or try to drive that average down. Other places, okay, so lots of places. I pay attention to politics, so we got political polls. Those are huge right now. It's 2012 as I'm recording this, so that's going to date this, but political polls are big. There's a really good site called 538.com that uses statistical analysis to try to analyze elections. Right now it's analyzing the presidential election, but it does it for congressional elections as well. Other stuff, pardon me. In our work, that's all just like entertainment and life skills type stuff. Use it in our work all the time. As an economist, I collect data. I'm an experimental economist, so I collect data on experimental subjects. I have them come into my lab, and then I write usually like a little video game, and they play the video game, and then I experimentally vary one of the parameters. So I randomly assign some people to play a game where one of the parameters is 1 and one of them where one of the parameters is 2, and I say, okay, well, what happens to people's behavior when the payoff is 1 versus 2, right? I use statistical analysis to take the 30 people I managed to get into the lab and use that to try to extrapolate to the population at large. What else? You pick books because they're bestsellers. You pay attention to the student-teacher ratio in schools. If you're in a production environment, quality control matters. Right? So, quality control in production. In a 6 Sigma methodology, 6 Sigma, what they're trying to do is they're trying to produce only 1 defect in, not 1 defect, 3.4 defects per million products. That's a lot of good products and not so many bad ones. That's very good quality control. To make sure this is the case, though, we have to set some control limits, and then when stuff gets outside the control limits, try to adjust the production specifications. That's how we, you use control limits. You test samples of your products to see, are we staying inside of our control limits? In marketing, you need to know if people like a product, right? So in marketing, you have places like the NPD group. I don't know if you've ever been a NPD group or a Nielsen family. Right? Nielsen, they do the ratings for TV. And what they do is they look at just a subset of the population. Somebody I knew worked for the NPD group, so for a little while we kept consumption diaries. And so in my family we would write down, what kind of cereal did you eat today? What did you have for lunch and stuff, right? And we'd send that to the NPD group, and then they could use that in their marketing, in their market analysis. They could target advertisements as a result of that sort of thing. There's a lot they could do. The internet has made it possible to, to track click-throughs, right? So, if you have advertisements on Facebook or on a blog, you can track click-throughs and say, okay, well, how often does this advertisement work? And much more frequently, people have been using A versus B experiments, where a marketer will test two different messages, market messages, to try to see which one seems to work better. That can be really effective. You can get a lot of information very cheaply about the efficacy of a marketing message. So that's marketing. Let's see, what else do we have? Accounting. Accounting, we got a few things, a few places where you run into statistics. One is you got auditing. Well, auditing everybody is really expensive. And if you want to try to target those audits better, what you can do is you can randomly sample for audits. And then, if you find an anomaly, then you can use correlates. Correlates are characteristics that people have in common. So if you find 4 or 5 accounts that seem like they have errors, then what you can do is you can drill down on the accounts that seem similar to try to figure out where to apply your efforts. And again, the reason you're doing this is because it saves money. It's economical. What else? Well, if you're interested in forensic accounting is when people use statistical patterns that exist in reality to try to find problems. For example, leading digits follow a certain law. It's called Benford's law. So if you have somebody who's recording, let's say, expenses for a company, then the leading digits of those should follow a specific law. That means if they're naturally occurring, right, there's a way to know how they're distributed. They're distributed logarithmically, and you can look to see, well, are they distributed logarithmically? Final digits are supposed to occur uniformly, but usually people round. Often people round, and if that happens, then there's another known distribution. And so all of these are sort of distributions that you would expect. You expect the world to look a certain way, and statistics can help you tell, does this quantitative world look the way that I expect it to look? Finally, finance, right? So everybody knows very recently lots of things have been going on with finance, and this is the ultimate problem, right? What we have here is we have signal and noise, and the question is, what is the signal and what is the noise, right? We have underlying value and statistical noise. So, can you make predictions about the way the noise will work? That's, technical trading deals a lot with that kind of stuff, right? Do you know how the market will move? And then value trading is, can you discern the underlying value? Can you tell if a firm is undervalued? In addition, financial analysts use lots of things like price-to-earnings ratio or dividend yields to try to base their judgment about the value of something. But in addition, they can use statistical analysis to try to get an idea of what the risk profile of a particular stock is. They can use this to construct portfolios that will satisfy their customers, their clients' preference for risk. Now, in all of these cases, what we're really interested in, statistics in each of these cases is just helping people do part of their job. And what that part of their job is ultimately meaning, right? They're trying to construct meaning. And That's where all of this kind of comes together. Is what we're looking at here is we're really looking at meaning. We're taking the world, information, and we're creating meaning. Right? We'll collect data. We turn that into information, which we use to get our meaning, and then that informs the collection of more data. And I probably can erase this arrow. But that's how it works, right? So we're using data to get information, to get meaning. But ultimately, what we care about is the meaning, right? This meaning leads to results, right? Or action. And this action is what we really care about. Right? We want to know what to do. Statistical analysis just tells us what the world looks like. If you know what the world looks like, then you know where to go next, right? Before we had statistics, you just had to make a lot of guesses. They're informed guesses, you do the best you can. But once you have the data and you know how to turn that into information, right, then that can help you to create meaning. It also can help you to motivate getting more data. But this is what statistics is. Next video, I'm going to stop here. We'll talk about data, what they are, and ways of categorizing them, ways of thinking about them, and where we can get data. So hope this has been useful, and I will see you guys soon. Thanks. Bye. Bye. You can see me now. Bye.